So this video is going to cover the quotient rule. We're still on section 2.3, and I've written down 3 examples I'm going to go over in this video, and you'll see the quotient rule, and the notation I use is the letters T and B. The letter T stands for the top function and B for the bottom function. And so this is the formula that I'll be using. So it's the derivative of a quotient function. So it's just a function that consists of a fraction where the numerator and denominator both consist of, I guess you can think of them as smaller functions. And it's equal to the bottom function times the derivative of the top function minus the top function times the derivative of the bottom function. And then all of that's divided by the bottom function squared. All right, so that's the formula. So now I'm going to apply it to number 11. So for 11, the top function is going to be x, and the bottom function is going to be x minus 5. So our top function is going to be x, and then the bottom function's x minus 5. So I need to find what's the derivative of the top function and the derivative of the bottom function. So the derivative of the top function, since it's just x, it's 1, right? The derivative of x is 1. And for the bottom function, its derivative, so x minus 5, the derivative of x is 1, and derivative of negative 5 is 0, because that's a constant. So you'd have 1 minus 0, which is 1. So they both have the same derivative of 1. So now I'm ready to plug it in and find the quotient rule, apply the quotient rule. So f prime of x So according to our formula, we have the bottom function times the derivative of the top function. The bottom function is x minus 5. And the derivative of the top function is 1. So that'd be x minus 5 times 1. So I'm just being extra careful here and writing everything out. Minus the top function times the derivative of the bottom function. The top function's x, and then the derivative of the bottom function is 1. All right, so this is just direct substitution into the formula, and all of that's divided by the bottom function squared. So that's x minus 5 squared. Okay, so then it's just simplifying, and really I have x minus 5 times 1 is x minus 5, and then negative x times 1 is negative x, and you'll see that since I have x and negative x, those are going to cancel out. So I can go ahead and cancel these out since that's x and negative x, and I'll be left with just the negative 5 part. So it would be negative 5 divided by x minus 5 squared. And then that's it. That's going to be the answer. Now I did not expand out x minus 5 squared. You want to keep it in its factored format. So I'm just keep it as is, as x minus 5 squared. Okay, so that's number 11. The next one. And I'm going out of order because number 13 is going to consist of a little bit more algebra than the other ones. So number 15 is g of x equal to sine x over x squared. All right, so I'll write down the quotient rule in a second. So I'm going to pause the video and have the quotient rule written down. All right, so I wrote down the quotient rule, so that's what we have with the right, and now it's a matter of matching up everything according to the formula. Now my top function sine x, so that's what t is going to be. The bottom function's x squared, so that's what p is going to be, x squared. All right, so I need the derivative of the top function. So t prime, that's going to be cosine x because we know the derivative of sine is cosine. Now b prime, the derivative of the bottom function. Since I have x squared, I apply the power rule. And based on the power rule, it's going to drop down the exponent, so it'll be 2 times x. And then it's raised to the 2 minus 1, which we know is 1. So really that's 2x to the first power, which we could just write as 2x. All right, so that's the bottom function derivative. So now I'm ready to find g prime of x. All right, so I use the bottom function times the derivative of the top. Bottom function is x squared. The derivative of the top function is cosine x. Then minus the top function, sine x, times the derivative of the bottom function, which is 2x. And all of that's divided by the bottom function squared, and the bottom function's x squared, so I'm doing x squared squared, or x to the 4th. All right, so that's plugging it into the formula now. It's just a matter of trying to simplify if I can do that. All right, so I would have g prime of x squared minus, or cosine x, minus 2x sine x. And then x squared squared, you just multiply the exponents, so that's x to the 4th. And notice I have x's through all of the terms from the top and bottom, so I can cancel out an x. So that would reduce the x to the 4th to x cubed. It'll reduce the x squared to just x. And then this x will just go away. So I have x cosine x. So technically I'm factoring out an x and dividing x out. So that's x cosine x minus 2 sine x. All of that's divided by x cubed. And then that's it. That's going to be our answer. There's no more simplifying I can do. All right, so that's number 15. Now this next one, I went out of order and skipped 13 just to do 15. So we get ourselves warmed up. So 13 is going to be more involved. It's just going to be more algebra. So for 13, my top function, so it might be beneficial to write it as the following: x to the 1/2 over x cubed plus 1. All right, because we know that the square root of x can be represented as x to the 1/2 power. So I'm going to pause the video and write down the quotient rule. All right, so I paused it and wrote down the formulas. So that's the quotient rule. Now I just need to identify, well, my top function is going to be x to the 1/2, or the square root of x. The bottom function is going to be x cubed plus 1. So if I were to find t prime and b prime, so t prime That's the derivative of x to the 1/2, which I would use the power rule. And I drop down the 1/2, so it'd be 1/2 x. And then you do it to the 1/2 minus 1. Well, 1/2 minus 1 is negative 1/2. So I'm going to go ahead and write this as x to the negative 1/2. All right, that's t prime. I think I'll leave it like that for now and then worry about simplifying it after I plug into the formula. Now the bottom function is x cubed plus 1. So the bottom function's derivative, using the power rule with x cubed, that's 3x to the 3 minus 1. Well, 3 minus 1 is 2. So really this is 3x squared. And then the plus 1, derivative of 1 is 0 since that's a constant. So really it would be like plus 0, but we don't have to put the plus 0. Just leave it as 3x squared. All right, so now I got all the different components that I can use to plug in the formula. So h prime of x. So the bottom function times the derivative of the top function. The bottom function's x cubed plus 1. Derivative of the top function is the 1/2 x to the negative 1/2 power. All right, then I subtract out the top function times the derivative of the bottom function. So minus. All right, the top function was square root of x, or x to the 1/2. So I'll just leave it as that and then worry about simplifying it into the radicand format. And then I have the bottom function's derivative is 3x squared. All right, so that's the top function times the derivative of the bottom function. Now I divide by the bottom function squared is x cubed plus 1 squared. All right, so simplifying this is going to require a good bit of algebra. So that's what I'm going to focus on now. All right, so for the first part, we have x cubed plus 1 times 1/2 x to the negative 1/2. Now I could write this as the 1/2 x to the negative 1/2. I could write it as 1 over 2x to the 1/2. But x to the 1/2 is the same thing as square root of x. So I'm going to go ahead and change the x to the 1/2 as square root of x. All right, and then minus. And I'll write this x to the 1/2 as square root of x. And then I'll put the 3x squared first, just because in previous math classes, some reason they want to put the radicand at the end. So I have 3x squared and then the square root of x because of the x to the 1/2. All right, so h prime of x. So the x cubed plus 1 times 1 over 2 square root of x, you could put the x cubed plus 1 in the numerator and combine it as one fraction. So it's x cubed plus 1 divided by 2 square root of x. All right, that's what that combines into. And then I have minus 3x squared square root of x. And all of that is divided by the x cubed plus 1 squared. All right, so ideally I want to combine the numerator into one fraction. And if I just focus on combining this into one fraction, just so focusing up top here, and I want to combine this into one fraction to simplify it down. So I'm going to focus on that for a second. All right, so the 3x squared square root of x, you could technically think of that as that 3x squared square root of x over 1. And I want to combine this into one fraction with the common denominator. And the common denominator is 2 square root of x. So the first fraction already has that denominator. It's just manipulating the second fraction so that it has 2 square root of x for its denominator. So I need to multiply it top and bottom by 2 square root of x. All right, so what that's going to give, so I have x cubed plus 1, and then over 2 square root of x, then minus 3x squared square root of x times 2 square root of x. Well, I do 3 times 2 is 6, so that'd be 6. And then square root of x times square root of x makes x. So I have x squared times x, because of the square root of x is multiplying together. And all of that's over 2 square root of x. All right, now I can have the same denominator, so I'm going to combine to one fraction. That's going to give me x cubed plus 1, and then minus 6x squared times x is minus 6x cubed. And then all over that common denominator of 2 square root of x. All right, then I can combine x cubed with minus 6x cubed to make minus 5x cubed. And then plus 1. All of that over 2 square root of x. All right, this is the numerator portion simplified. All right, so going back to what we had. So we have h prime of x equals, and now the whole numerator portion that was doing all the simplifying in green turned into this, negative 5x cubed plus 1 over 2 square root of x. All right, that was what the numerator turned into after I simplified, and still on the bottom I still have this x cubed plus 1 squared. Now, whenever I have this fraction divided by some number, I could attach this to the denominator of the fraction above. So I can go ahead and attach this to the denominator. So that will give me h prime of x equal to, so up top's negative 5x cubed plus 1. Now I have 2 square root of x times x cubed plus 1 squared. And that's going to be the answer. So this is why I did this one last, because of the algebra. So the calculus part really was just right here. And then everything else is algebra manipulation. All right, and then that is finally the answer. Okay, and I can explain this step where I have this purple arrow indicating you can just go ahead and attach it to the denominator. But this is the answer to the problem. So this is just an added comment for how I was able to just go ahead and put that to the denominator. So here's my aside. All right, and you could just know from here on that you can do that. Now, the explanation for why I can do that is if I wanted to simplify this, the x cubed plus 1 squared, you can think of that as x cubed plus 1 squared divided by 1. And if I wanted to, if I multiply the top and bottom by its reciprocal, so it would be 1 over x cubed plus 1 squared. And what I do on the bottom part, I do up top. All right, and so the denominator portion, I could go ahead and divide these out. And so I'd be left with up top the negative 5x cubed plus 1 over 2 squared root of x times x cubed plus 1 squared. All right, that's where that comes from. I just skipped having to show that just to make things less cluttered. So yeah, anytime I have like a over b, and let's say that's divided, that itself is divided by something, let's say it's called c, then that's equal to a over b times c. All right, so that's, you can just think of it like that, and this is why. And this aside, just showing you an example. So like this would be like your a over b. And then the x cubed plus 1 squared is like the c. Okay, so that is some examples showing the quotient rule. And for this one in particular, it was just a bunch of algebra steps that was making it complicated. The actual calculus, I don't think was that difficult, because it's just this part's the actual calculus, and then from here on, it's simplifying it into a reduced format. And that it requires your knowledge of square roots and like exponents and combining stuff into one fraction, which is what I was doing here. So I combined the numerator portion into that one fraction. And then after that, then I attached the denominator portion, x cubed plus 1 squared, to that denominator of 2 squared root of x. And then that gives me my answer. And there's not much more I can do. I have it already in reduced format for it being factored. All right, so next video is going to be just more examples from this section. And it's just going to be a mix of examples, whether you use product rule, quotient rule, or maybe some examples where you don't have to use the product rule or quotient rule.